Hello, here's a review. Um, let's talk about formats. Um, First, what is a format? There's a couple answers to this, right? Number one, switch to the laser pointer. That is not better. I will not switch to the laser pointer. Okay. Number one, it's this band right here. So on a spectrogram, it's the band that denotes more energy. In this case, it's a brighter band. In some cases, it's a darker band. So the ones that we've looked at in other slides have like a white background, and then the as you get more energetic, it's darker. So it's whatever is denoting more energy. Um, Brighter in these colorful ones that I have, in the black and white ones, it's usually the darker stripe. But the answer that I'm looking for here is it's the resonance peak. So think back to the previous exams, we're calculating resonance peaks. What is the first, second, and third resonant frequency of a tube of this length? Well, that gives you the resonance peak, which becomes the format. So the individual harmonics that fall into that format get amplified, and that's what creates this band of formats here, and here, and here, and here, and here, and all of those all the way. What relationship does the speech tube have with formats? We kind of already talked about this, but the length of the tube and the place of constriction determine the formats. So we already talked about length of the tube, right? So how long the tube is going to determine your resonance peaks slash formats without constriction. You just have a length, and that's going to determine where your resonance peaks are. If you have had 310 with me, you know that there's a little bit of shortening that can happen in the length of the tube. We haven't really talked about that in here, but it can for different like types of like emphasis. You tend to shorten the length of the pharyngeal tube, which is why we don't really talk about it. It's just like some things that happen during speech. But in typical running speech, you might not shorten your pharynx very much. Instead, you use constriction where your tongue is going to be, um, or your tongue, or like how tight your pharynx is in the back, to determine what's happening to the resonance peaks that you've already calculated. So remember our schwa 500, 1500, 2500. That's just the base unstressed version of a sound that comes out of the pharynx, the speech tube, pharynx in the mouth. And then if you put your tongue high and forward, that pushes around the formats. If you put your tongue low and back, that pushes the formats around in a different way. So it's the length of the tube and it's the placement of the constriction. What is the name of the thing? This is not on this review, but it's also an important thing to know. What is the name of the thing that the name of the theory that deals with constriction placement? It's perturbation theory. That's right. So perturbation theory is why we're talking about the place of constriction. Okay, what is a spectral envelope? Whoops. Well, we're not. I can't have you answer, so that's okay. What is a spectral envelope? Pause it if you want to answer. It's the overall shape of the spectrogram. So how the harmonics of the fundamental frequency are shaped by the pharynx. Basically, you just connect the dots. You do an FFT, fast Fourier transform. you get all the little harmonics doing shapes like this. And then the spectral envelope, you're just going to connect the dots. That's a spectral envelope. You'll see formants in there. So if you have something kind of like this, there's your formant, and then it comes down and you just connect the dots. What are the axes of a spectral envelope? Well, one is frequency. So if you have it like this, frequencies along the bottom here, these are going from, I guess in your view, this is low frequency and it's going to go over to high frequency. And then the other is amplitude. How tall these bars are the amplitude. This is low amplitude everything. This is high amplitude everything. And then what are the axes of a spectrogram? That's what I've got on the screen here. What are those axes? Time, frequency, and amplitude is in there as well. Time is along the bottom. So time runs right to left. Nope, sorry. Left to right. It's hard to know directions. Left to right. Same direction you read. Yeah, just had to make sure. Yeah, that's right. Frequency is now up. So frequency is moving up. And then amplitude is how bright that bar is. Or dark if you're looking in the other spectrogram. But in this case, it's how bright it is. Okay, let's talk about vowels. What are the axes of the vowel quadrilateral? There's 4. What do you think they are? Oh, I'm thinking of corner vowels. I misread my own question. Okay. Tongue advancement and tongue height. Tongue advancement up this side. Tongue advancement along the bottom. Tongue height up the side. Which means the corner vowels are, this time there's 4 of them. Corner vowels are E, U, Ah, and Ah. And what's right in the middle? Schwa. So schwa is kind of like sitting in the middle. It's the nexus. And then everything moves out from the schwa. What is the F1 and F2 pattern of a high front vowel? First of all, what is one of our high front vowels? Well, E, of course. I feel like that wasn't supposed to show up yet. But that's okay, because we're not doing it in class where you can give me answers. So it's fine. It's fine. It doesn't matter. High front vowel, OC. Oh, that's just to show you the corner vowels. I see what I've done. This is showing you corner vowels. It's also showing you what's going on. With everything in here, it's hard to see my cursor, but here's the tongue. More towards this side over here is tongue towards the front. So front vowels are over here. And then the back is back vowels. It's, kind of self-explanatory, but that's where the tongue is. And then also blue. So all of your blue, arrows are what the tongue is doing. And then in this axis, it's tongue height. So here it's high, and then all the way down here it's low. So a high front vowel would be E. A high back vowel would be U. A low back vowel would be Ah. A low front vowel would be Ah. And then in purple here, I've got what's going on with the front cavity. It's longer when you're towards the back here. It's shorter when your tongue is towards the front. So if your tongue is towards the back, you have a longer front cavity. If your tongue is towards the front, you have a shorter front cavity. And then we can also look at what's going on with the pharynx on this same axis. So when your tongue is low the pharynx is narrow. And when your tongue is high, the pharynx is wide. Just think about the tongue as being like a long slab of meat, because it is. And so when you lift your tongue up, E, it's hard to see. E, tongue's all the way up. It's pulling the tongue up. There's not as much tongue to be down here in the pharynx. Versus ah, tongue's low, and there's more tongue back here in the pharynx. So if the tongue is high, the pharynx is wide. If the tongue is low, the pharynx is more narrow. Okay, F1 and F2 pattern of a high front vowel. Why? It is F1 low and F2 high, of course. What is the pattern of a low back vowel? Let's jump back and see what the low back vowel is. It's ah. The pattern of a low back vowel: high first formant, low second formant. So high front is low F1, high F2. Low back vowel, high F1, low F2. And what is the F1 and F2 pattern of a rounded high back vowel? Low F1, low F2. Lip rounding is going to lower F1 and F2. So let's take a look at these. And what I want you to tell me here is, which of these is most likely to be an E? Is it 1, 2, or 3? And then also, which one is most likely to be an oo? And which one is most likely to be an ah? Well, this is an E, this is an ah, and this is an oo. So from left to right, E, ah, oo. So notice formant 3, it's moving around a little bit. It's higher for the high front, it's lower for the rounded, but really the amount that it moves is not, it's not super drastic. So you don't need to worry about F3 when you're looking at vowels. But you do need to look at F1 and F2. So for oo, low and low. The F1 is almost as low as E for oo. E and oo have a pretty equivalent F1. But the F2 is absolutely the lowest for oo. It's also tanked. Now for E, which also has a low F1, it's got a very high F2. In fact, it has the highest F2 of any of them. And then ah is in the middle, looks not exactly like any of these because it's got a high first formant and a low second formant. So E, ah, and oo. Okay. Are vowel formants exactly the same every time? Exactly the same. No, they're not exactly the same. They're very close, but they're not exactly the same. How do we account for the inexact production? Like when we're interpreting what people have said to us. Categorical perception. Things that are close, we perceive them as the same. Do men and women exhibit the same formant patterns? Well, sure. They may not be exactly the same formants because there's a contribution of vocal tract length. But it's the same patterns. Absolutely. An E is going to look like a low F1, high F2 for any speaker. The pattern doesn't change. Just the exact number. Do different languages exhibit the same format patterns for the same phonemes or similar phonemes? Yeah, of course. Totally. It's all physics, right? It doesn't matter where you're from, it doesn't matter who you are. The physics needs to move the same in the vocal tract. So the same format patterns are going to create the same perception. If it's an E in German, it's an E in Spanish. If it's an E in English, if it's an E in Yoruba, if it's an E in Mandarin, it's still an E. And you can only create the E in one way, which is putting the tongue high and front, which is going to, because of perturbation theory, push F1 down and F2 up. It's just physics. Okay. Oh, so let's take a look at these vowels. What I've got here is 4 words. Just looking at the difference in the vowels, we've got puppy, peanut, poppy, which I meant like Poppy, like the flower, but it could also be poppy, like I poppy. You know, that's fine too. Whatever, however you want to do it. And then lastly, Pikachu, because I couldn't come up with anything else that started with a P and an E. Peanut and Pikachu were like the only things that were appropriate for the slideshow. So puppy, P-E. So we've got 2 things here. We've got our which is close to an and we've got our E. So you can see right here, this is our high F1, low F2. Actually, I'm telling you a lie. Because this little bar of junk down here, is there any way to get rid of that? No. This little bar of junk down here is in my way of my FO. Sorry about that. Okay, so actually what we're seeing is F1 is about here. F2 is right there. This is F3. And you can see that for the E, that's F3 right there. That's kind of sliding up a little bit. This is F2 right here. You can see it kind of slide up a bit from the P also. So there's F2 and then there's F1 all the way down there. So we've got high F1, low F2, and then moving into the E, we've got low F1, high F2. Peanut, you can see, is doing the opposite because the E comes first here. So we've got low F1, high F2, and then peanut. And it's kind of like making the transition from the N. And you can see this F2 jump up. And, sorry, F1 jump up and F2 move down to get to the There's also some great stuff going on here for all of our other phonemes that I'll point out really quickly. So I tried to focus everything on being like a P word. So puppy, poppy. And you can see that there's really no preferred place of energy for the P. The P is everywhere. Here, pretty much everywhere. Here, it's pretty much everywhere. Here, it's pretty much everywhere. So no real preferred place. For the T, you can see that that is not the case. For the T, you can see that you still got that, like, here's the stop, here's the burst, and you can see that the energy is concentrated up here at the top. For the K, you can see that, you might be able to see that the energy is here and here. You've got 2 distinct bands, like making a K on the spectrogram. And then we've got the chew, which is like a T plus a sh. And it's hard to see this exactly, but there is a bit more energy up here at the top of this T that moves into the sh here than down further. So it follows the same pattern as this T. Next, poppy. You can see that it's kind of following a very similar pattern to puppy, puppy, poppy. The formats have moved around just a little bit for that difference in intonation, ah. But you can feel there's not a lot of difference between and ah. And then the E is in almost exactly the same place. Puppy, poppy, here and here. Then Pikachu, the E, again, doing the same thing that it was here. Low F1, high F2. Pika, now it's lower. So this F1 is jumping up. You can see it right here. It's higher than it was here. And F2 is on its way down, lower than this E over here. Pikachu. So we've got a sh right here. And you can tell that, well, we don't have anything to compare it to. You can see the shape of it is very noisy. So that tells you it's some sort of fricative. We'll look at the difference between S's and SH in a little bit. And then oo, Pikachu. Of course, we have low F1, and then you can see F2 right here just like dipping down to meet the F1. So Pikachu. You can see this transition here into the oo. Okay, that's vowels. Let's talk about diphthongs. How many diphthongs are there? There are 5 or 6. I'm not going to trick you with that question. The answer that I'm going to have is 6 is not going to be an option. So go with 5. What are they? They are. Let me amend what I just said. 6 is not going to be an option unless I say 5 or 6. So you'll have either 5 or 6. What are they? They're ow, o, ow, I, a, and oi. And you. How do you differentiate a diphthong from a vowel? The format transitions. Diphthongs have rapid format transitions, although not as rapid as semivowels. Those format transitions don't exist in a single vowel, so we didn't see anything back here in puppy or poppy. We did see some stuff going on here with the in peanut, where the is kind of like resolving out of the n. And then you can also see a similar thing here where the oo is resolving out of the sh. So Pikachu. So they shouldn't exist in a single vowel, but you can also see that those were pretty shallow transitions when you're transitioning into a vowel from a consonant. Pretty not very slopey. But here, when we're looking at diphthongs, it's quite a bit faster. You get more of like a roller coaster action going on here. Right here. Boing, boing. Just like that. Much more rapid. Is a diphthong an exact blending of 2 vowels? No. And there's a couple ways that this is true. I'm only going to tell you one because the second one that I was going to ask you about is the next question that I have on here. So is the diphthong an exact blending of 2 vowels? No. Because if you look at ow, it doesn't go from o to oo. It doesn't go oh. It goes ow. So there's less movement in the diphthong. We say that it goes from o to oo. We say that it goes from ah to I. By the way, some of those have little e's on them, and they should actually have capital is. So, sorry about that. We don't move that whole distance. We'll kind of, so if your first sound is here, and that's not going to work for you. If your first sound is here, your second sound is here, you're not going to start here and move here. You're going to start here and move here. So it's kind of like a trajectory thing where you're starting near that vowel but closer to where you're going, and you're stopping before you get to the next vowel. So it's shortening the distance. That's also true for time. So the timing of a diphthong is shorter than two independent vowels. So e is much longer than I. Well, that's actually not one of the sounds, but I. So if you had what word says doesn't matter. Versus I, much faster to say the diphthong. But it's longer than just one vowel. So I is longer than but it's shorter than two vowels by themselves. So it's like 1.5 vowels long ish, if you want to think about it that way. So kind of in the same way that you don't start on the vowel and go to the next vowel, you don't just add those timings together either. It's a little shorter. That's where we get those rapid format transitions. Okay, what we have here, it's one of the few that I could actually make like a sentence out of pretty quickly. This says, "Hi, soy boy, want to go out?" And so we've got our H, my favorite of all of the consonants, which you can tell is very quiet. Much quieter than this vowel over here because it's just high. So you've got the quietness, kind of looks a little bit sort of like a fricative, except what does it have in it? It's like a fricative with formants. And a fricative with formants is not something you tend to see. You see like big groups of energy, but you don't necessarily see formants. So you tend to only see formants with an H. And that's because your mouth is already getting in position to say I. So ha, ha. See where there's no movement. Ha. It's already in the right place. But if I say he, see, the mouth has changed from hi, he, but the H doesn't get any special movement. Like I'm putting my mouth in the place to be there for the vowel. There's no specific movement for the H. And so what you end up with is just this thing that looks like a quiet fricative, but it has formants, and the formants are the same formants that you will see in the next vowel. That's how you know that it's an H. So we're going I, so high, and then here's our F2, jumping up. Here's our F1, falling down. In the H, there's no voicing. So that's another way to notice it's an H. Here's F1, here's F2, up here's F3. Then it drops of course, is high first format, low second format. Goes into an E, I, which is close to an E. So first format's going to drop, second format's going to jump. And then we're going to go into soy. And so starting that is a sibilant. No other sibilant to compare this to yet, so that's okay. We just know that it looks pretty noisy, much noisier than the H. And then we have oi. So O, low, low. O is rounded. oi, and then goes into a high front vowel, or really close to our highest front vowel. So o, low, low, and then it's going to get a little bit lower for the high front vowel, but F2 is going to jump up. And then you can see a similar thing going on here with boy. So, but there's the stop and then the burst. And then it's all over just like a P. Energy's everywhere. So boy does the same thing. Here's F1. It's going to drop. F2 is going to rise. I want to show you something else really quickly. So you might notice that coming out of the S right here, we get this little drop to the O, oi, I. That's because look where your tongue is. Look and feel where your tongue is when you say an S. Tongue is up, kind of close to where you make an E. Soy. So it has to like fall from an E placement, oi, and then come back up, which is why you see a little bit of the remnants of that right there in that fall. And then buh, lips are together, but tongue isn't up there, which is why you don't see that transition out of it here. You just see buh, oi. Hi, soy boy, wanna. And so, w is very rounded. Everything's fallen way down here. So, F1's popping up, F2's popping up, wa, and that's kind of close to our over here, right about in this region. Right here, one. There's an N, one. G. There's a G. You can see there's energy here, and then another spike of energy up here, and then we're going into O. So we're falling from an O to an U. O. So we're getting a little bit more rounded. F1 is going to fall a little bit. F2 is going to fall even more. And then I have a W that's kind of in parentheses here, because when you say go out, you get a little bit more rounded on that first O, and then you kind of have a pause. So what you're seeing here is a little bit of extra rounding, a pause, a short pause before out. You can see the transition is beginning before the voicing stops. So go out. And then we start again. Go, ow. We start back where we were up here. Ow. And then everything falls to get to that lip rounding. And then here's a T, which has energy towards the top. Okay, semivowels. The first question is over on the right side. How can you differentiate semivowels? It says semivowels behind my head. How can you differentiate semivowels from diphthongs? They have even quicker format transitions, and they tend to be a little quiet. What do some semivowels look like? Well, the w is similar to an oo. It's just a little bit more constricted. And the y is similar to an e. Why did I put a y? It should be just a little I. I don't know what I'm thinking. The y is similar to an e, just a little bit more constricted. How is L different from R? Well, R has a very large drop in F3. Think about third drop for R. I'm going to try to come up with a pirate-themed mnemonic there, but it wasn't happening. What is a semivowel? They're consonants that are acoustically similar to vowels. So, w, ol, Am I asking about semivowels? Yeah, I ask them about down here. So let's skip that. Are there obvious formants in semivowels? Yeah, dude. There are. That's what makes them semivowels. What are the semivowels? W, L, and Y. Okay. Sorry about that yawn. What do we got here? We've got ring, wing, ling, ying, thing, sing, and zing. So I put a little bit more in here than we needed just to look at semivowels, but I think it's nice to have these up against one another here. Okay, so first, ring. Well, what you're looking for is that third drop. So look at the third format for everything. Here's the third format. Here's the third format. Here's the third format. But here, dropping down, is the third format. Sorry. Just got into like a yawn habit all of a sudden. It's because I'm saying zing? That doesn't make any sense. So here's your third format, and you see this just like drop way down for the ring. You can see it pop out of it into the E. You can really see that it's the only third format that has that big of a drop. So R really is characterized by that big third drop. Okay, then wing is characterized by first and second formats just shoot all the way down for a W. What we're looking at here, they're not coming down, they're coming up out of the W. So wing, we're going into the E. You can see that first and second formats are just very rapidly shooting up and out. Okay, ling, you've got your second format coming up. It's low for the L. But here you can see it popping up, and third format doesn't do much movement at all. Second and third, I should say. No, just third. Third stays put, second is this drop right here. And then ying has a special thing that it does as well. So R has the third drop. W is a lot of constriction. L, you just see this second format has a little bit of constriction, not as much as W. And then ying is very similar to E. It's just a little bit more constricted. So you'll actually see as we go from Y into E, we're going to go ying. So you can see that it's dropping a little bit into the high front vowel. High front vowel already has low F1, high F2, and this is coming from even higher than that high F2. So ye right there. And then it's rising up a little bit to the low F1 from the more constricted ya. What do we have next? Thing, sing, and zing. So a couple differences that I want to point out here. All three of these are fricatives, but you can see that the TH is less intense than the S or the Z. You can also see that both S and Z, they're made in the same place. S and Z have high frequency noise. So they look all noisy because they're fricatives, but they have more high frequency noise. Both of them do. The S has a little bit more high frequency noise than the Z does. And the Z is the only one so far that we've looked at with this voicing bar right down here, because Z, it's a voiced consonant. So zing, you're going to see a voicing bar down here. The S, you don't see it. The thing, you don't see it down there either. Okay, next. What is the intensity hallmark of a nasal? Intensity hallmark of a nasal. It's quieter. There's less intense overall, but you can still see some visible formants. What is the acoustic hallmark of a nasal? Well, there's two things. First of all, there's anti-resonance. The first thing we've seen so far with anti-resonance. It's not the only thing with anti-resonance, but it's pretty pronounced in the nasals. And then second, there's a nasal resonance that's somewhere between 250 and 300. And it's the same for all the nasals produced by the same speaker. It'll have the same nasal resonance. Different speakers may have slightly different nasal resonances, but not crazy different. Which nasal has the overall lowest anti-resonance? M. That's because anti-resonance is related to the size of the closed-off tube. That's my answer to my next question here. The oral cavity, so mouth is closed. The air is coming out through my nose here, which means that the oral tube is just a place for energy to get trapped. And because the M is made at the very front of the mouth, I've got all this distance right here for waves to collect. So it has a longer tube, which means it has a lower anti-resonance. You can see that you can leave your mouth open when you say because it has a shorter tube, which means it has like a middle anti-resonance. And then ing, you can leave your mouth open even more because you're even further back and it has the highest anti-resonance. So is lowest, ing is highest. Does the nasal resonance change with the phoneme? Not at all. And the reason for that is because we have no musculature up there to be sufficient to create perturbation theory. You can't do it. So all you can do is just change where your anti-resonance is. And hope for the best. Because the nasal resonance is going to stay in the same place. It's all related to the length of your nose and the pharynx and nose together. Okay, what do we got here? We've got summoning and naming. Nasals. So summoning starts with an S. We've got this kind of like noisy thing here with high frequency energy. We know has a high F1, low F2. And now we've got some. So going into the M, we've got some lip rounding. Some. Similar to so. So you've got lip rounding. You can see that F1 drops, F2 drops, some. And then we're going to sit here for a little bit. And you can see a little bit, not a ton, a little bit of anti-resonance around this spot right here. And then we're going to go into some, it should be summoning, but it's not pronounced that way. So it's like summoning. So here's your and then we go into the N. Summon. Okay, so the energy here looks the same. The nasal resonance is way down here, just like it was for the N. We've got now some anti-resonance up here. Summon. So anti-resonance up there. Summoning. And then here we've got low F1, high F2. And then ing. And ing is quieter than the and the n. And you can also see that there's more. It looks like you've got some anti-resonance here, but then you've also got some here which moves down a lot lower than the n or the So there's a lot of anti-resonance for ing. And then over here with naming, Well, we're starting with the N. So we've got energy down low. N. And then we've got anti-resonance here. A little bit higher. Nay. Back to the M. This M, I don't see as good of anti-resonance right here. It should be there. Just, I guess, not the way I say it. And then name ing. Here's your ing. And you've got big anti-resonance here and low anti-resonance. Now we're going to go to fricatives. What are the major subgroups of fricatives? This is kind of easy. It's sibilants and non-sibilants. S and SH are the sibilants. What makes a sibilant? This is not in the slides, but you do need to know it. What makes a sibilant? The obstruent. Your tongue. S, sh. The tongue is the obstruent. F and th don't have the tongue in the same place where the air is hitting the tongue. So they're just fundamentally different. They're not a sibilant. S and SH have narrower tuning. You can see that here in this bottom graph. What does that look like in the spectrogram? It means that there's more intense and condensed energy than the F and the V. So it's louder, and then the energy is also like condensed into one place. Not quite a formant. It's a lot wider than a formant, but it is a noticeable conglomeration of frequencies. What effect does antiresonance play in sibilants? It's there. It's definitely there. It's also based on the length of the back cavity. So when you say you have a short front cavity, but you have a really long back cavity. And when you say shh, it's maybe a little closer to equal. Medium front length cavity, medium back length cavity. All right. This is the same thing, but this time I have some spectrograms for us to look at. So we've got suffer fever. That's not right. Suffer shover. That's what I wanted. Suffer shover. And fission vizier. They started getting weird at some point. Okay, so suffer shover. Look at the difference between the S and the SH. S, it's a little higher. The peak of energy is a little bit higher. And then sh, it's a little bit lower. If we jump back, you can see the same thing. The S peak is a little bit higher. The SH peak is a little bit lower. So suffer. And then the F that you can see there. There is no real peak of energy. It's just kind of everywhere. It's very different from the S, which does have an obvious peak of energy. Okay, so suffer. I don't notice the third drop in that. Yeah, that's because it's the postvocalic, so it's a little different. So we wouldn't see as much of a third drop there. Okay, let's look at shover. So we talked about the SH, and then we go into and then we go into V. Shover. So V and F, same phoneme, but one is voiced. And what I want you to notice about this is, number one, there's a voicing bar that moves all the way through right here. So V has that FO energy, and F doesn't. Number two, V is shorter than F because it's voiced. So you have more information there. The F is just by itself. Lastly, it's a little bit quieter. Suffer shover. The voiced ones become a little bit less loud, a little bit quieter. Okay, and then fission vizier, I think another really important thing to look at here is the F and the V that start off the words. Again, V has the voicing bar, V is shorter, and V is a little bit quieter. And then F has no preferred bands of energy, just the opposite of this S over here, which does have very high preferred bands of energy, and this SH, which has middle high energy bands. Okay, so fission. There's another look at an N, but we don't need to talk about that. Fission vizier. Okay, there's another Z. That might be our first Z. So S and Z are made in the same place. S and Z. And you can see that the Z also has this high frequency energy, but it's got voicing. And it's a little quieter. Again, voiced consonants tend to be a little quieter than their unvoiced counterparts. Okay, and that is fricatives. What does voicing look like in a spectrogram? We just talked about this. It's S versus Z. It's a little bit of FO that still exists in the spectrogram. Sometimes we call it a voicing bar. That's the difference. Which is longer, voiced or unvoiced? Well, unvoiced. That could be the laryngeal devoicing gesture, or it could be an accumulation of information. Make the ones without voicing longer because there's not as much information contained in the phoneme. What do sibilants or non-sibilants look like? What? Oh, which is longer, sibilants or non-sibilants? I wrote this freaking thing. Why did I forget what I'm asking right there? Okay, so which is longer, sibilants or non-sibilants? Sibilants are longer. Which fricative is very quiet and retains formants from vowels? The H, my favorite little ghost. Why? We talked about this. The mouth's already positioned for the next vowel. And what is turbulent noise? It's air passing through a partially obstructed cavity. So the vocal folds are partially adducted to make that sound for the H. There's your ASMR for the day. What are the stops? And then I didn't make that go away. So you get a free answer. B and P, D and T, G and K. What are the stops of a hallmark? That's not right. What are the hallmarks of a stop is what we want. The hallmarks of a stop are the silent interval. That's the stop. The release and the frication interval. The silent interval is what we're going to use to like identify that there's a stop even there. So you're looking for a little gap. Then you're going to confirm that you're right, that you're looking for a stop when you see the burst. So the burst is just where the, air is finally released. So you get that nice hard line whoosh, 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 for each one. And then the frication interval is going to give you information about which specific phoneme was used. And aspiration, yes. What is VOT? VOT stands for voice onset time, and essentially it's when voicing begins for any of these phonemes. We don't have to only use it for stops because there's other voiced consonants. The problem with that is if you say azupa or something like that, you never stop voicing from your vowels. So it's hard to say that there's something like a voice onset time for the or the, things like that, where the voicing can run all the way through. Because there's not a built-in stop. We know there's a built-in stop for stops. And so that allows us to measure voice onset time relative to the release in the stop. What role does anti-resonance play in stops? Well, it exists here too. It can help identify the stops, and essentially it's the same kind of thing. It's related to the size of the back tube. So T is going to have lower frequency anti-resonance than G, because I'm moving the tube back. I'm shortening the tube. Shorter tube, higher frequency. Okay, which stop has the longest anterior tube? Anterior tube meaning in front. Posterior tube is the one that relates to anti-resonance. Posterior meaning behind. So the posterior tube is related to anti-resonance. The anterior tube is in the front. It's related to resonance. Well, G and K have the longest anterior tube. G and K. And then we're going to talk about affricates for a second here. Affricates are combinations of which two sounds? They're putting stops and fricatives together. The timing of an affricate is very similar to the timing of a diphthong. So an affricate is longer than a stop or fricative by itself, but it's shorter than a stop interval. But it has a shorter stop interval and a shorter frication interval. So it's kind of doing the same thing that the diphthong is going for. It's longer than just one, but it's got some shorter components in it that make it shorter than two phoneme units. Okay, let's look at what we have here. We've got pump, bump, dump, tump, gump, and cump. Not all of these are real words. Although Gump, Bubba Gump Shrimp Company. So we've got P and B. First of all, big difference is voicing. You can see the voicing in the B, but not in the P. So the voice onset time is negative for B. I start voicing these way before I have the release of air. The second thing to notice is that there is no preferred frequency where the information, where the acoustic information is being released. P all over, and that means B all over. That really sounds like someone's mantra for their life. P all over, B all over. And I guess it's probably like a dog. So buy your dog a little shirt with that phrase on it. I might do that. Okay, dump and tump. Big difference between these. Voicing. Here's our voicing. It's a little bit shorter for duh. But it's longer than tuh. And then you can also see that both of these have energy higher up in the higher frequencies. So here's the maximum, it looks like, about right around here for duh, for dump. And then here it is for tump. Just no voicing. Unvoiced a little bit louder. And then looking at the difference between gump and cump, we see that gump, of course, has the voicing bar. You see the two bands of energy, low and mid. And for k, you see again low and mid energy, where the energy is trapped in the burst. Okay. It's also worth noting that all of these have another p at the end of them. So you can see the same thing going on there. It's a little more subdued because it's just the end of the word. So pump. You get a lot more energy in the first one. Pump, dump. But the last one's kind of like getting a little quieter. Even so, you can see the same thing. There's energy pretty much everywhere for the P. No one preferred place. Okay, these are the same bullet points we just talked about. And I put in this. Okay, so this is the thing has hats, is what this says. The thing has hats. I wanted to show you a couple differences between the and thing. So, of course, one of those things is the voicing bar. The has voicing and th does not. Again, you can also tell that the voiced consonant is a little quieter than the unvoiced consonant. It's also a little shorter than the unvoiced consonant. This is all true. This holds true for all of our consonants. And for both of them, no preferred place of energy. So they don't look like an S over here. Here's an S. You can see that there is a preferred place for energy. It's up in the high frequencies. Okay, so the thing, here's another NG. The thing. And for some reason, I've got like this little extra schwa at the end. The thing. I don't know what that is. The thing has hats. So two of the same phoneme. You can barely see this second Here's the H again. Already has the formants that it's going to need for the so the thing has, there's the energy for the S up there. Hats. There's the energy for the S up there. Here's a T. It's difficult to see where the energy is in that T because the energy is in the same place for S. So they kind of are overlapping one another. But you can still see the stop interval and the release. Okay. And then once again, these are the same bullet points. I've just got another picture for you. This is adjacent hatches. And so that's looking at our affricates here. So we've got adjacent. So for these affricates, you get a stop, just like a stop. And then hatches. Look at the length of the j and the ch. And if I go back, there's a t. The thing has hats. More space for this stop. But remember, there's a shorter stop interval for affricates. So affricates have much shorter stop intervals, and here they are. Look at that tiny little stop interval there. Adjacent hatches. So here's another S. Here's an E. Here's a diphthong. There's just an an N, and then a T. Energy in the top. S, energy at the top. Hatches. The Z against the S. Obviously, you can see the voicing bar down here. Other than that, they look pretty much the same. The energy is in pretty much the same place there. You can also tell that there's shorter frication interval for the j and the ch. Let's go back again. Is this where we want to be? No. There we go. So our frication interval, where we're seeing the frication intervals, where we're looking for the energy to differentiate one from another, you can tell that there's actually quite a bit in a lot of these. There's a decent amount in the K and the G. Gump and cump. There's quite a bit of energy right there, quite a length of energy. And if you move forward to adjacent hatches, you see that that's not it. There's adjacent hatches. You don't have as much energy right there. Not as much time for it. Not for the T part of adjacent hatches. So it's much shorter. It goes into the sh portion much more quickly. Same for the adjacent. The D, you've got just about this much distance to cover for the D, and that goes into the G right there. Okay. Adjacent hatches. Anything else I want to talk about in adjacent hatches? Doesn't really look like it. We can sort of see some differences between this T and this TSH. The energy's in the same place as this little bit of information for the T. And then, of course, this goes right into the sh, which is a lot easier to see here. That the sh is got energy a little bit lower than the S. The S is all the way up. The SH is a little bit more towards the middle region. Yeah, okay. That's adjacent hatches. And then here's our last slide, which is I just want you to know which consonants are what. And then I've got some notes in here as well. So the length of tube, I've added over here. Length of tube gets shorter as you head, gets longer. Sorry, length of the anterior tube gets longer as you head down. Ba, not really any tube. Labiodental, fa, there's a little bit of a tube. Then thigh, there's a little bit more. Seal, we're getting a little bit longer. Shiel or ash, about halfway through the mouth. Then coal, pretty far back. And all the way back at glottal, we've got ha. So PB, TD, KG, those are all stops. Fricatives, we've got a lot of fricatives. F and V, th and the, s and z, and then sh and j, and then also ha. Just whispering. Affricates are easy. We've got ch and j. Nasals are also easy. M, n, and ing. And then semivowels, not too bad. Behind my head is a W. W, ul, and y, r. Okay. You get high resonance with T and D. You get lower resonance with K and G, but you also remember you get that shape of a lower one and a middle one. Fricatives, your lowest resonance is going to be, don't worry about H, because it retains the formants of what value you're going into. So that's not what I'm talking about with lowest resonance. Lowest resonance you get with the sh versus the sa. So you're going to see the peak of energy shifts down a little bit. With the affricates, they're both in the same place. So really what you see is voicing is the difference between those. Has the lowest anti-resonance. Ing has the highest anti-resonance. That's all due to the size of the this unused cavity in here, the mouth, the size of the mouth. Like what wavelength of air can get trapped inside the mouth. And then wa is a lot of lip rounding, like an O or an oo. Ul and are kind of their own thing, and then ya is very similar to an e. There's a couple other lessons that we should take from this when we go into an we're heading towards lip rounding. So wa is very similar to ma, like where we're coming from and where we're going to. They make totally different sounds, and wa, but they are both rounding the lips. Okay, I think that's everything. Yeah, that's all I've got here. I would recommend taking a look at your knowledge checks again, and any of the quizzes that we've had. If you have questions, send me an email. I'll be around pretty much all day tomorrow. I'll be in my office for a decent amount of tomorrow. And if you're on the patio for the gift bags, I will be there as well. So let me know if you have any questions. And good luck.